So our actual frequencies should be as follows. The high frequency should be f prime equals f over 1 minus vf over vs over v sound, where vs is positive. Vs positive means that the source is moving toward the observer. So that's going to give us 1 minus 0.037 in the denominator. 3,000 hertz over 1 minus 0.07 really turns out to be close to 300 hertz times 1 plus 0.07, which is what we used in our original estimate. The low frequency should be what we get if the source is moving away from the observer. If the source is moving this way and the observer is over here, this is what we expect. We expect that Vs is going to be negative, and that this will then be a negative ratio of 0.037, and that subtracting the negative will end up with a positive. So we have 3,000 hertz over 1 plus 0.037. We can compare these results with the estimates that we made. 3,000 hertz times 1 plus 0.037, 3,000 hertz times 1 minus 0.037. Notice that here we're dividing by these factors and here we're multiplying. But of course when we get the high frequency, we're dividing by 1 minus or multiplying by 1 plus the 0.07. To get the low frequency, we're multiplying by 1 minus 0.037 or dividing by 1 plus 0.037. Now these results, if you take your calculator and punch this in and punch this in and punch this in and punch this in, this will be very close to this and this will be very close to this, but they won't be exactly the same. They're very close only because this number 0.037 is small. So as we said before, we can only make this approximation with a 0.037 factor. The approximation, this is an approximation down here, this is the actual, this is the approximation. We can only make these approximations if this number is pretty small compared to 1, like less than 0.1, let's say, will give us a pretty good result. But as the number gets bigger, the result gets less and less accurate.